Alright. So, here's your homework assignment. Everybody alright? Yes, no, maybe? So, up first is number 4. Can I please get the system? Or, real quick, how many equations in the system? Just 2? Okay. And? Just 3x? Alright. So, first things first, when we solve the system by graphing, we have to be able to graph each part of the system. So we look at each line, and we want to get the line so it's into a regular format. So what that means is that if they give you one variable, you want to isolate that one variable just like we always do, and if there's one variable, it'll be a vertical line or a horizontal line, right? If there's 2 variables creating a skew line, then you're going to want to isolate which variable. Which variable do we isolate for skew lines? The y. So, equation 1 is y isolated. Okay, then we're done with that part. Equation 2 is y isolated. Alright, super easy. So, we're going to be graphing using our regular old M and B slope-intercept form, right? So, if you're looking at these and you're like, I don't know what to do. It's y equals mx plus b. If there's 2 variables, if there's 1 variable, isolate the variable. Everybody good? Alright, so what's the m for this first equation? 5 over 1. What's the b? Y here. Or m here, 3 over 1 and b, 0. Right, remember, if there's no b, it's a 0, right? So if you don't see anything added, it's a plus 0 out there chilling by itself, right? Alright, so first, I want you, and I'm going to need you. Alright, first line, where do I start, m or b? No, b. What's our b? 2. So that's the y-intercept, right? And then what's my slope say? How do I get my second point? Up 5 and over 1. So, on my graph, I start at 2 on the y-axis, right? So remember, the b is always your up and down. And then I go up 5 over 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. So go down 5 over 1. Come on. Come on, ruler. There you go. Good boy. Laugh if you want, it works. Talking to technology like it's a real thing. Well, you know what I mean. Like it's a living thing. Right. So there's the first line. Everybody good? Yes, no, maybe. Any questions? Yes, comments, concerns? Yep. So what we do is when you solve a system by graphing, you create each part of the system on the same coordinate plane. So you just graph each equation in the system on the same graph. And then you want to look and see how many times do they intersect, right? Or are they the same line? Everybody good? Yes? All right, second equation. Where do I start, m or b? B, and what's my b? 0, and then what's my m? Up 3 over 1, right? So 0, 1, 2, 3 over 1. 1, 2, 3 over 1. So there's your graph, right? How many times do they intersect? Once, none, or infinitely many? 1 time, right? Now, a part of this that a lot of people forget to do is the directions don't say just graph it. What do the directions actually say? Estimate the solution and then verify that your solution actually is the solution to the system. So first things first, right? So this is actually a multi-step problem. All right, so the first thing that we have to do is graph the solution, or graph the system. Where does it look like the 2 lines are intersecting at? What coordinate? -1, -3. So we think this is the solution, right? Okay, now what I have to do is I have to verify that that is, in fact, the solution. So if I think that this is a solution to the system, I'm going to put a big question mark over it. If that's a solution to the system, again, what does it mean to be a solution to the system? You have to satisfy which part of the system? Everything, right? So what does it mean to satisfy? Okay, so how can this point make the equation happy? Okay, you plug in your x and your y, and you want something that is what? True. Okay? So if this is a solution to both equations, then it is a solution to the system. Is everybody good with that? So I need to see this on your paper where you substitute the value back in. And most of you don't do this, which is why a lot of you lose points on this homework. So is negative 3 equal to negative 3? Okay, then just circle it. If it's true, you just circle it, and that means, yeah, we're good. Everybody right? In order to be a solution to the system, you have to satisfy everything. So if there's like 5 equations, you have to plug it into all 5. Do the same thing over here on the second equation. Whoops, that's a 0. What's 3 times negative 1? Negative 3 plus 0. Negative 3, right? Is negative 3 equal to negative 3? Yes. So you just circle it, right? And what if something is not a solution? How do we mark it? Slash. Okay, so if you get to something and it's not true, you put a slash to the equal sign, and you're done. And what that really means is that this point is wrong. So you have to regraph the equation. Yeah. You have to find the solution to these. That's what the directions say, right? The first thing says find the solution to the system, not verify if your first guess is right. Okay? So if you get the wrong coordinates here and you get something that isn't true, you have to go back to the graph and figure out what happened because this intersection that you thought was going on is not correct. Is everybody all right with that? Yes or no? So when you do this, you should get 2 true statements out of here. Or not should, actually. You have to get 2 true statements out of here. If you don't, then this is wrong and you have to go back to your graph to figure out why. Everybody good? Yeah? So be careful because some of you, what you'll do is I'll ask you to find the coordinates here and you'll go y first. So instead of writing it as negative 1, negative 3, you'll write it as negative 3, negative 1. So that way when you verify, you'll get wrong answers. Okay, that doesn't necessarily mean that your graph is wrong and you have to erase everything, which is what a lot of you do is blow it up and start over. Okay, if you get something that's not true, go back to your graph and double check what you did. See if it's right. Check your M, check your B. Make sure it's what you had on the previous section when you found them. Everybody okay with that? Yes, no, maybe? So just be careful, okay? But if you're careful through this section, you should be fine. All right, number 5. Again, what are the 2 parts of the system? And okay. So first equation, how many variables do you see? 2. So this is going to be a skew line. So how do we graph a skew line? What do? Isolate what? Y. Okay, for the first equation is y isolated. Yeah. All right. So I can just jump down here, find my M, find my B. What's my M? Negative 1 over 1, right? Because you got to grab the sign. And then what's the B? Everybody good? All right, second equation is y isolated. No, so what do? Okay, so how do I move it? Negative x? Everybody good so far, yes or no? Okay, now how do I finish off? Divide by what? Negative 3, right? Good catch, Jordan. So you get negative x over 3 plus 1 over 3, right? Everybody good with that? Yes? No? Maybe? Okay. So what's your M? What's your slope up here? Negative, right? And then what's your B? 1/3. Everybody good, yeah? Alright, so first line, what's my B? 3, and what's my slope? Negative 1 over 1. So I go up to 3. Do I drop or rise? How far? And then I run which way, left or right? How far? I just want to make sure I can hear you guys if you have something to say or ask or answer. All right. So everybody okay with the first line? Okay, second line, what is my B? Negative 1/3. So that's like here, and that's a really bad color because I'm writing on blue, genius. B is positive 1/3. Okay, so that's here. Gesundheit. Everybody okay with that? Okay, now do I rise or fall? Fall how far? 1. Now, I fall 1 from 1/3, right? So, like, what's 1/3 take away 1? Negative 2/3. Okay, so what that means is, you see how this is above the 0, right? So if I were at 0 and I went down 1, I'd be at 1, right? Okay, but the distance between the 0 and here, I have to maintain that. So if I drop 1, I'm going to be, like, here. Everybody okay with that distance being actually 1 unit? All right, so just be careful with that, because what happens with fractions is y'all are usually pretty good at placing b, but then when it's time to use your m, you go down to just -1 instead of negative 2/3. Because remember, you're taking your b value and you're either adding or subtracting from it, okay? So for us, 1/3 minus 1, which is my rise value, is negative 2/3. Everybody good? Okay, now from here, though, so I'm here, right? I went down 1. Which way do I run, left or right? How far? So I'm about there. All right. So let me graph my line. There you go. How many times do they intersect? Once? Like 1 time, no times, or infinitely many times? 1 time. And where at? Yeah, but we need precision, right? Because we have to test it. So you're right as far as the starting point. It looks like it's right around 4 -1, right? It's a little bit over 4 though, right? 4 and about a what, do you think? Well, 4.5 is here. Yeah, what I would do is, what fraction has already been kicking up? Like, what was this value? 1/3, right? I would start there. I might be wrong. It might be a quarter. It might be a half. But a third, because I've already had thirds, is a good idea. Okay, so I'm thinking this is 4 1/3, comma, -1 and what? -1 1/3. Everybody okay with that? Yes, no, maybe? So because your fractions already have a third as a denominator, there's a really high chance that that denominator is going to work for us again. So if you have like halves, right, if your slope is like 5/2 and it's a decimal, you should start with a half. Everybody okay? All right, so now we have to check it and see if this works. So I'm trying to check if 4 1/3 -1 1/3 is in fact a solution. I don't know. So let's plug it in and see what happens. -1 1/3 equals -4 1/3 plus 3. Everybody okay with that? So if you get rid of the parentheses, you get -4 1/3 plus 3. What is -4 1/3 plus 3? So what's -4 plus 3? -1. So I get -1 1/3. Is that true? Okay, so far, at least we're half right. Okay. Thank you, computer. All right, and then plug in. So -4 1/3 minus 3. Yeah, they take a while. Yeah, well, I hate to be mean to you guys, but basically everything we deal with in this entire class are big applications. So this is considered a basic skill. Yeah, because it's combining everything from chapter 2 that we've already done. And you've already seen it before. Yeah, so everything builds on itself. So like next year, you're going to be sitting there going, man, I wish we were doing this stuff from last year, because it'll seem not easy but not as severe. Because we're going to be using these skills next year in different applications. Okay? No, not quite that bad. But like solving equations and stuff, you're going to be doing that, but on bigger equations, powers, all kinds of stuff. Okay? So this year is really important, because think of this year as like building your basic skills. Okay, if we get this year and you're paying attention and you know what's going on, then next year when we actually start applying all that knowledge, you'll be ready to go. All right, if you don't pay attention and you don't get the stuff you need this year, next year is going to kick you in the teeth. And if you mess up next year, it can cost you your graduation. So this year is actually really important. All right, but if you keep working, I'll get you to wherever you need to go. So I get -4 1/3 plus, what's 3 times 1? Oh, that can't be right. I know. You don't need to remind me. Either way, I'd get the exact same answers. But -3 times -1 1/3 is going to be +4, right? Is negative 1/3 equal to negative 1? No. So that means that our point was off. Yeah, so all of this means nothing. And we get to go back to the graph. Woo! So let me isolate y up here. The graph isn't totally wrong. Okay, then why did I miss? What happened? Because it's 4, negative 1, right? So I'm close. Well, no, it's got nothing to do with you guys. Am I perfect here at 2/3? No. I'm guessing, right? So, I know I'm close, right? So, what I'm going to say is you probably should not have fractional answers for your point unless it's really obvious. Like, if it looks like it's about a half, it'll be a half. Okay, you shouldn't be dealing with quarters, thirds, eighths, anything like that. Okay, so it's either a whole number or a half for your solution. Everybody okay with that? Yeah? Yeah, but you were. Okay. I was going to try to make some mundane point, but I can't because you were correct. All right, so 4, negative 1 is my point. Everybody okay with that? Now I still have to verify and check. So I'm checking for negative 1. Negative 1 equals negative 4 plus 3. Negative 1 equals negative 1. That's a check. Negative 4 minus 3 times negative 1 equals negative 1. Negative 4 plus 3 equals negative 1. Negative 1 equals negative 1. That's a check. Everybody okay? Yes, no, maybe? So graphing fractions, sometimes things get a little wonky. All right, and the reason is because we're not able to be precise. Okay, because I don't have things measured off perfectly where I've got a ruler and making sure it's exactly 2/3 of the total distance and all that. Everybody okay? Yes, no? Okay, so what that means, though, is that if I got something that wasn't true, that means my point's wrong, right? So I have to go back to my graph, double check your M and your B. Double check, sorry. It's just the look on Wes's face. All right, so double check your point, right? And then get as close as you can. So if this point doesn't work, look for something really close nearby because you're just a little bit off. All right, remember, because this is a line, it doesn't take a lot to be, or it doesn't take much to be off by a lot, right? Because we got 5 minutes. What's 26? And everybody good? All right, and what do the directions say to do? Okay. So I'm going to have to cook through this, so keep up. Yes. That's the only method we have for solving right now. So that's going to be negative 1. That's going to be 2x. Oh, super easy. Done. Fantastic. How many solutions? So are the slopes the same or different? Same. So that means that it's either an infinitely many number of solutions or it's no solution, right? So we have to look at the b's. Do the b's match or are the b's different? B's are the same. So these are actually what? Same line. So how many solutions? Infinitely many. Not just a few, guys. Infinite. Okay, so remember your options are one solution.
If the m's are different.
No solutions if the m's are the same and the b's are different. And then if the m and b both match, it's infinitely many, which means they're coexistent. Okay? So what do we call a system that has a solution? Is that inconsistent or consistent? Consistent. Okay? And then what do we call something that has an infinite number of solutions? Independent or dependent? Dependent. So this is a consistent dependent system. Everybody okay? And then you can graph that, right? Negative 1 up 2 over 1, connect the dots. Both lines are actually the same line, so you only have to graph one line. Well, you got it right. Yep. It says solve the system. So for us, we're going to have an infinitely many number of solutions, right? So infinitely many number of solutions.